Welcome back, everyone. Today we are going to be learning about triangle midsegment theorem. In the very last video, you just learned about solving for missing angle measures and side measures when we're talking about similar triangles. Now we're going to talk about the midsegment of a triangle. It's important that you know the definition of a midsegment of a triangle. The endpoints are the midpoints of two sides of a triangle. For example, RP is a midsegment of this triangle ABC. PQ is also a midsegment. RQ is also a midsegment. You can use all three midsegments together to create what's called the midsegment triangle. For example, triangle RPQ is the midsegment triangle on this triangle ABC. Now, something is special about the midsegment triangle. A midsegment of a triangle is always parallel to one side of the triangle, and its length is half the length of that side. So for example, you know that FG and JK are parallel, and you also know that JK is equal to half the length of FG, or you can do it the other way around. 2 times JK is equal to FG. Let's try to use this in a problem. It says in the figure, segments XY and XZ are midsegments of triangle RST. So we're looking at this big triangle. We know that these two segments are the midsegments of the triangle. That means that Z must be the midpoint of ST and Y must be the midpoint of RT. That might be helpful at some point. Let's see what they're asking us for. They want us to find the length of segment XZ. So let's look at segment XZ here, segment XZ here. I know that it would have to be parallel to RT and half the length of RT. So let's write that down. XZ is equal to half RT. I know the length of RT is 13, so I know it's half of 13, so XZ must be 6.5. Let's try the next one. It wants us to find ST. That's this segment here. I know ST is parallel to this midsegment, XY, and it would also be twice the length of the segment XY. So let's write that down. ST equals 2 times XY. So if XY is 7, that means ST must be 14. Finally, we can also use this to find angles since we know parallel lines. We're trying to find the measure of angle RYX. That would be this angle right here. Now, let's see if we can find any lines that are parallel. I know that X, Y, and ST are parallel, but that doesn't help me create an angle with the one that I already know, 124. So let's go ahead and look at a different pair of parallel lines. We could look at RT and XZ. With these parallel lines, I can use one transversal to connect the angle I know to the angle I'm trying to find. These two angles, ZXY and XYR, are alternate interior angles. That means that since the lines are parallel, those two angles must have the same measure. So we'll know the measure of angle RYX is also 124. If you need to make a note to yourself, it's because of alternate interior angles. Remember, this only works with parallel lines, but in the case of the midsegment triangle theorem, we know that it gives us lines that are parallel, which means these angles will have to be congruent. I would like you to try the next problem on your own. Here are the correct answers. Finally, I want you to answer this reflection question. Are the original triangle and the midsegment triangle similar? Explain why or why not in 1 to 2 complete sentences. That's all I have for you today. Tomorrow we are going to learn more about parallel lines and their proportional parts that they create. I look forward to teaching you about that next. See you then. Bye.